Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 20A. Let's start with the second sum. The lengths of the sides of a triangle are in the ratio 3 ratio 4 ratio 5. The perimeter is given and the area is asked. Whenever ratios are given, we take the common multiple as x. So we let the sides be 3x, 4x and 5x. Now perimeter is given as 144. So 3x plus 4x plus 5x is 144. Solve this, get the value of x, substitute and get the sides. Now we'll find the area with the help of the three sides. We can't use the formula half into base into height because we don't know the height. So we'll have to use Heron's formula. First, we find the semi-perimeter. No need to add them, we already know the total perimeter as 144, so half of that is called semi-perimeter, which is 72. And Heron's formula is this: semi-perimeter into s minus a, s minus b and s minus c. There should be a c out here, where a, b and c were the three sides. So you find the difference here. Now we have to find the square root of this. No need to multiply this. You have to prime factorize it and take out pairs to find the square root. I'm not going to find the prime factors. I would do a shortcut method. I can see that 72 is 2 into 36. So I got a couple of 36 out here. And 24 is 2 into 12. So I got two 12s out here. And I've also got two 2s out here. So whenever we remove square root, each pair is written only once now. And the square root sign, which I call the umbrella, disappears. And just multiply them and you get the answer. This is the area. Now the fourth sum. The area of an equilateral triangle is given as 36 root 3 square centimeter. Find its perimeter. There is a direct formula of area of an equilateral triangle, which is root 3 upon 4 into sides squared. So we'll use that formula because root 3 will get cancelled. And then we find the value of side, which turns out to be 12 centimeters. Next, they've asked us to find the perimeter. That is 3 times the side because all sides are equal. So that's 36 centimeter. Now in the sixth sum, the base of an isosceles triangle is 24 and the area is given. Find the perimeter. Mark this as an IMP sum. Now there are a few ways to solve this sum. The method I'm going to use is, the base is given as 24 and the area is also given, but we know that the area is half into base into height. So using the area and the base, I'm going to find the height, which turns out to be 16 centimeters. That means AD, that is the height, is 16 centimeters. By the way, the base was entirely 24, that is BC. In an isosceles triangle and even in an equilateral triangle, the altitude always bisects the base and it is perpendicular in fact. So that is a property we are going to use here, that AD is perpendicular bisector of BC in isosceles triangle ABC. Always mention the properties being used, otherwise you would lose marks. The reason why we are using this property here is because this means DC is 12 and also angle D here, ADC, is 90 degrees. So if DC is 12 and AD is 16 in a right angle triangle, we can use Pythagoras Theorem to find AC, which will turn out to be 20, which you should know beforehand because 12, 16 and 20 are Pythagorean triplets. but you'll have to show the working. So AC squared is AT squared plus DC squared, Pythagoras theorem. In triangle ADC, always mention the triangle in which you are applying the Pythagoras theorem. Substitute the value, solve and get the value of AC, and it's an isosceles triangle. That means AB and AC will be equal, both will be equal to 20, and now we can find the perimeter as 64 centimeters, the addition of all three sides. Another method would have been, the base is 24, let's take AC as well as AB as x, because in isosceles triangle the two sides are equal. So I got the three sides. So perimeter would be 24 plus x plus x. So I just want to find the value of x, but how do we do that? Well, area is given. So use Heron's formula. Use these three sides to calculate the area of triangle ABC, which is already given as 192. Solve and get the value of x, and then get the perimeter as well. That will be a bit longer method. Next, the eighth sum. In every sum, you must draw the diagram. Freehand diagram is okay with pen, but you have to draw a diagram in geometry for every sum, whether the diagram is given in the question or not. Here they've asked us to find the area as well as the perimeter of the entire quadrilateral. So here AB is given, AD is given, and BD is given. That means we can find the area of triangle ABD by Heron's formula. And for this triangle we have BD and we have DC, the hypotenuse. We can use the formula half into base into height, but the base BC is not provided. So first we'll find that by Pythagoras theorem. So in triangle DBC, use the Pythagoras theorem, get the value of BC, the base, find the area of that triangle by half into base into height. Now for the other triangle ADB, find the semi-perimeter, use Heron's formula and get the area. By the way, root 7's value is unknown, so we'll have to find the value, which is 2.645, using long division method. You may have studied this in lower standards. Let's solve it till 3 decimal places. So we'll put 3 pairs of zeros after the decimal point. We start off with 2. 2 2s are 4. Remember, the number out here and the number out here should be exactly same. I can't go for 3 3s because 3 3s is 9. That is bigger than 7. So 2 2s are 4. Yes, you have to show this in the rough working. Remainder is 3. Now here the entire pair of 0 will be carried forward, carried down. There's a decimal here, so put a decimal here as well. 2. So whatever number we wrote here, just add that. So that becomes 4. Now fill in the blanks. The number here and same number here. The number here and here should be same. It could be 45 5s are, 46 6s are, 47 7s are. Any number which is not greater than this, but just less than this. So 46 6s fits because 47 7s will be too big. So 46 6s is 276. Remainder is 24. Now carry down the other pair of zeros. We wrote the number 6 here, so please add 6, so that becomes 52. Again, a number out here and the same number here. Try various values in the rough work. It's a very long process. 521 1s are, 522 2s are, up till 524 4s are. 525 5s are will be too big a number. So 524 4s are 2096 and the remainder is 304, and then carry down the final pair of zeros because we want answer up to 3 decimal places. Again, we had written the number 4, so add 4, so that becomes 528, and now another digit here and the same digit here. 5285 into 5 becomes 26425. No need to solve further. We got the quotient here, approximate value of root 7. We got it. Also notice how I had left a lot of space in the beginning because I knew that this one digit will go on to become a 4-digit number. So the 2.645 is the value we are going to use, and that way we'll find the area. We can round it off to 2 decimal places as well. So area of quadrilateral would be the sum of area of two triangles, which is this. rounded off value. Now when they talk about perimeter, it means only the fence, the boundary. That will be AB plus BC plus CD plus AD. No need to add DB while finding the perimeter of the quadrilateral, because BD is in the interior of the quadrilateral. So after addition, we get the answer as 36 centimeter. Now the 10th sum, mark it as IMP. Ignore these notations of 8 JBP written here. That's not for y'all. In the 10th sum, again the ratio of the sides is given and the perimeter is given, so we know what is the first thing to do. We let the sides be 5x, 3x, 4x. Using the perimeter, we'll find the value of x and the 3 sides. They've asked us to find the area first of all. So find the semi-perimeter and find the area. Notice how I have not found the prime factors of these numbers. Rather, I've just written this as 30 into 3 because I can see a 30 already there. And I've written 45 as 15 into 3 because I could already see a 15. So 30, 30, write it once. 3 and 3, write it once. 15, 15, write it once, and the umbrella goes away. And the area is 1350 meters squared. In Roman number 2, they want us to find the altitude, that is the height, corresponding to its largest side. The largest side is 75 centimeters. So 75 meters. So taking that as the base, we'll have to find the height. So area we've already found out. Base we took it as 75, so we can find the height, which is 36 meters. And third, cost of leveling the field. The cost is always either area into rate or perimeter into rate. But how can we be sure whether we have to use perimeter or area in that formula? Well, if you think logically, the cost of leveling the field, when you are leveling the field, you are leveling the entire area and not just the border area. If it was cost of fencing the field, then the perimeter would be involved. But this is leveling the entire area of the field. A big hint is the rate. If you look at the unit of the rate, it's rupees 10 per square meter. So whenever it's square meter or square centimeter or kilometer, it means that the area comes into the play. If the perimeter or the length was involved, then the rate would have been rupees 10 per meter. There would be no square. So that's a big hint. So the cost is equal to area into rate, and we get the final answer. Next, the 12th question. Calculate the area and the height of equilateral triangle whose perimeter is 60 centimeters. Well, if the perimeter is given, we can find the side of each side of the equilateral triangle, because all sides are equal in an equilateral triangle. 20 centimeters is the answer. Using that, we can find the area using the direct formula. And root 3 value is known to us, it's 1.732. So we get the answer as 173.2 centimeter squared. Now to find the height, we will use the other formula of area, half into base into height. Base is any one side, which is 20. Area we have found out, so we can find the height, that is the altitude, which is 17.32 centimeters. Now the 14th sum. So the 10th sum was IMP, and so is the 14th sum, mark it as IMP. If the difference between the sides of a right angle triangle is 3 centimeters, its area is 54 centimeter squared. Find its perimeter. So we should draw a diagram here. It's a right angle triangle, let's say at B, and let's assume BC is x, so AB is x plus 3, because the difference between them is 3. We could have taken it as x minus 3 also, won't make a difference. And please mention the assumptions. Now area is half into base into height. You see the AB is not only a side of the triangle but also the height, because there's a right angle here. Area is already given. Base we took it as x and height as x plus 3. Distributive multiplications, open the brackets, rearrange the terms, you get a quadratic equation. We have to split the middle term. The middle term is 3x. Fortunately, the coefficient out here is 1. So 1 into 108 is still 108. Now I want to split it into two terms such that their product is minus 108, but their addition is 3. So if you can't do it mentally, just find out all the factors of 108 first of all. It's 1 into 108, 2 into 54, 3 into 36, 4 into 4 into 27, 6 into 18, 9 into 12. These are all the factors. Now, the multiplication of all of them will give me 108, fine. But the addition of which of the pairs will give me 3? It turns out the perfect pair would be 9 and 12. But what about the signs? Plus 9 plus 12 is 21. No. How about minus 9 plus 12? Yep, that would give me plus 3. Or how about 9 and minus 12? That will give me minus 3. Let's see what is the middle term. It's plus 3. So let's split it as 12x minus 9x, because 12 minus 9 is plus 3 and 12 into minus 9 is minus 108. Be careful with the signs. Also, if you write minus 9x first and then plus 12x, it doesn't matter. Now, out of these 4 terms, pair these two together and these two together. Let's take out something common. What is common between them? X. So what is left is x plus 12. Minus common always, if there is a minus sign here, and 9 is common between the two. What is left here? X is left. And if 9 is gone out, what is left behind? 12, because 9 into 12, if you do distributive multiplication by opening the brackets, you'll still get 108. By the way, put a plus sign here, because if you take minus common, then the inner signs will change. Notice how if you open the brackets, minus 9 into plus 12 will still give you minus 108. And a big hint is that this bracket and this bracket has to be the same, so that we can write the bracket common once, and the remaining terms I can write it in another bracket. So x plus 12, x minus 9 is equal to 0. That means either this is 0 or this is 0. One of them has to be 0. Only then their product is 0. Well, if this is 0, then x's value will be minus 12, which is unacceptable. We cannot have negative values of x in geometry. Negative lengths are not possible. How can the base of a triangle be negative? So x's value has to be 9. And if the base is 9, then the height has to be 12 centimeters. So I got the base and the height. All that is required now is the hypotenuse AC. So if this is 9 and this is 12, well, you should know the answer has to be 15, because that's another Pythagorean triplet. Of course, we'll show this step. Write Pythagoras Theorem as a reason, calculate the hypotenuse, and then find the perimeter, which is 36 centimeters.